The function of deep neural networks in detail from the input layer, hidden layer, and output layer. Let's dive into the details of deep neural networks, DNNs, focusing on each of the main components, the input layer, hidden layers, and output layer, based on RAI, Artificial Intelligence, template. DNN, Deep Neural Network. Pradeep K. Suri. Author and researcher. 1. Input layer. Function. The input layer is the initial layer of a DNN, and its primary function is to receive and transmit the input data to the subsequent layers for processing. Number of neurons. The number of neurons in the input layer is determined by the number of features in your dataset. Each neuron corresponds to a feature, and the values in these neurons represent the values of the input features. Activation function. In most cases, input neurons do not have activation functions. They simply pass the input values as they are to the next layer. However, you can use pre-processing techniques like normalization or standardization here. 2. Hidden layers. Function. Hidden layers are the intermediate layers between the input and output layers of a DNN. They play a critical role in feature extraction, pattern recognition, and learning complex representations from the input data. Number of hidden layers. DNNs are characterized by having multiple hidden layers, which distinguishes them from shallow networks. The number of hidden layers can vary depending on the complexity of the task and the architecture of the network. Number of neurons in each hidden layer. You can customize the number of neurons in each hidden layer based on the problem you are solving. The choice of the number of neurons can impact the network's capacity to learn and generalize. Activation functions. Activation functions are applied to the weighted sum of inputs in each neuron of the hidden layers. Common activation functions include ReLU, rectified linear unit, sigmoid, and 10. These introduce nonlinearity into the model, enabling the network to learn complex relationships in the data. Role in learning. Hidden layers are where the network learns to represent the data in a hierarchical manner. Each layer captures and refines different features and abstractions from the previous layer. This hierarchical representation allows the network to model intricate patterns in the data. 3. Output layer. Function. The output layer is the final layer of the DNN, and its primary function is to produce the model's predictions or outputs based on the representations learned in the hidden layers. Number of neurons in the output layer. The number of neurons in the output layer depends on the nature of the task you are solving. It corresponds to the number of distinct categories or values you want the network to predict. Activation function. The choice of activation function in the output layer depends on the task. For regression tasks, predicting continuous values, there is typically no activation function or a linear activation function. For binary classification, a sigmoid or logistic activation function. Thank you.